Today, we will see introduction to Boltzmann machine. Unit 4, Boltzmann machine problem. Next, we see the basics of Boltzmann machine before going into deeper. This one is Boltzmann machine. The Boltzmann machine was first invented in 1970. Geoffrey Hinton, the professor at the University of Toronto. He is a leading figure in deep learning community and is referred to God for deep learning. Boltzmann vision is a generative, unsupervised model which involves learning a probability distribution from an original dataset and using it to make inference about never before seen data. Boltzmann vision has an input layer, also referred to as a visible layer. One or more hidden layer, also referred as a hidden units. This is what the Boltzmann vision model. The red nodes are hidden nodes, the blue nodes are visible nodes. The Boltzmann mission looks like a web. All the hidden nodes are interconnected with all the visible nodes. The Boltzmann mission uses a neural network with neurons that are connected not only to other neurons in another layer, but also to the neuron within the same layer. This is what the Boltzmann mission. You see the picture, each and every neuron is connected to the other layer. That is, for example, visible unit, 1, 2, 3 nodes, and the hidden units, we have 7 nodes. All 3 nodes connected to the hidden nodes. Also, all the visible nodes connected to other visible nodes. So this is what the line says. Boltzmann machine uses neural network with the neurons that are connected not only to the other neuron in the other layer, but also in neuron same way. Everything is connected to everything. Connections are bidirectional. Visible neurons connected to each other. Hidden neurons also connected to each other. Boltzmann machine doesn't expect input data, it generates data. Boltzmann machine doesn't expect the input data, it generates data. Neurons generate information regardless they are hidden or visible. For Boltzmann, all neurons are same. It doesn't discriminate between hidden and visible neuron. For Boltzmann machine, all things are called system and it generates state of the system. So the nodes are connected with each other to the same layer or to the another layer nodes. So this is what the Boltzmann machine learning. Then where we use this Boltzmann machine learning? Yes, for social media data analysis or recommendation of a product or movie, we can use Boltzmann machine. So that you can generate data from the older data. So same wise, the Boltzmann machine doesn't expect the input data. It will generate a data from the previous history or something else so that it can give the solution to the future things. So that is what the major use of Boltzmann machine. Let's see this example. Nuclear power plant. The same scenario applicable to the Boltzmann machine. So for running a nuclear power plant, you have a different units are interconnected with one another to make a whole system working properly. Suppose, for example, we have a nuclear power station and there are certain things we can measure nuclear power plant like temperature of the building, then how quickly the turbine is spinning, the pressure inside the pump, etc. we can monitor. There are a lot of things we are not measuring like the speed of wind, moisture of the soil, whether the day is sunny or rainy. All these parameters together form a system. It's a complex pattern, but a complex pattern working together and to form a system. All these parameters are binary. So we get a whole bunch of binary numbers that tells something about the state of the power station. It's exactly the same scenario applicable to the Boltzmann mission. But Boltzmann mission also a binary, a bunch of a binary number, and it can give a solution by interconnecting all the nodes. What we would like to do, we want to notice that it is going to a unusual state. A state not like a normal state which we had seen before. And we don't want to use supervised learning model because we don't want to have any example of state. Okay? We would rather be able to detect the when it is going into such a state without even seeing such a state before. So same way, we do that building a model of normal state and noticing that this state is different from normal state. That's what the Boltzmann practice is. The way this system works, we use our training data and feed into the Boltzmann machine as an input and help the system to adjust to it. It resembles our system, not any nuclear power station in the world. It learns from the input. What are the possible connections between all these parameters? How do they influence each other? And therefore, it becomes a mission that represents our system. We can use this Boltzmann mission to monitor our system. Boltzmann mission learns how the system works in normal state through a good example. So, as I said, the Boltzmann mission consists of neural network with an input layer and one or more hidden layers. The neurons in the neural networks make stochastic decisions about whether to run on or off based on the data we feed during the training. And the cost function for Boltzmann machine is trying to minimize. By doing so, the Boltzmann machine discovers interesting features about the data, which helps model the complex relationship between the data and patterns present in the data. This Boltzmann machine uses neural network with neurons that are connected not only to another neuron in the other layer, but also the neuron within the same layer that makes the training an unrestricted Boltzmann machine very inefficient, and Boltzmann machine has very little commercial success. So this is what the introduction about the Boltzmann machine. Just recall what we learned about Boltzmann machine. Then we go deeper into Boltzmann machine and its types. Yes. The Boltzmann machine founded in 1985, and it's a generalized generative unsupervised model, and it has many input neurons, I mean, many more hidden neurons. This is what the uh, Boltzmann machine looks. All the visible neurons are interconnected with the hidden neurons. Also, all the visible neurons are interconnected to the another visible neurons. Likewise, hidden nodes also connected to the another hidden neurons and also visible neurons. It is look like a complete wave. Obviously, the Boltzmann machine used for the purpose of recommendation or social media data analysis or many more applications. The Boltzmann machine, before understanding the Boltzmann machine, we can understand the nuclear power plant, how it works. The entire plant is working with the help of all the hidden units and visible units are interconnected. The entire connection makes a system, whole system. The same way the Boltzmann machine works. So, whatever the data we are feeding as a training data, the Boltzmann machine learns from the training data and it regenerates more and more data And based on the data, it adjusts the weights of each and every neuron, and it gives some prediction or relationship between the data or pattern between the data, everything it gives. Based on this, we can come to the conclusion whether to uh, give, whether to, uh, for example, movie, whether to see the movie or not to see the movie. So in social media, many people are watching the movie and they are giving their own information about the movie. All those informations are given as a training data for a Boltzmann mission. Then Boltzmann mission analyze those informations from lakhs and lakhs of people, and it regenerates the patterns between the data, relationship between the data, and finally comes to the conclusion whether the movie is watchable to the particular age or this movie is watchable, uh, the rating of the movie, whether to watch or not. These kind of recommendations you can give to the network. So many applications are the Boltzmann missions are used in many applications. So that's what about the Boltzmann mission. Thank you and all. So next class we'll see restricted Boltzmann mission, introduction of restrict RBL. Thank you. Thank you.